Okay, sige. We will having na our short lecture. So our lecture today is for the overview of logic gates and Boolean algebra. Can you confirm kung nakikita niyo yung PowerPoint? Saka kung nag-aano siya, nagta-transition.
Yes, sir. Nakikita.
Okay, so for week 4, we will going to tackle Boolean algebra. And so first we have a short history or introduction for Boolean algebra. So last 1854, we have the logic algebra was published by George Boole, so known today as Boolean algebra. So before ang tawag ay logical algebra. And then as of today, known today or mas kilala siya ngayon sa tawag na Boolean algebra. And then it is a convenient way and systematic way of expressing, analyzing the operation of logic circuits. And then last 1938 with Claude Shannon, and he was the first to apply Boole's work to the analysis and design of logic circuits. So si Claude Shannon naman yung nag-apply nung Boolean algebra using for the analysis and design for a logic circuits. And then sa Boolean algebra, may tinatawag tayong operation and expression. So we have variable, a symbol used to present a logical quantity. And then also we have complement, the inverse of variable and is indicated by a bar over the variable. And then we have literal, a variable of or the complement of a variable. So before we discuss the Boolean algebra, we will also tackle the overview of some logic gate symbols. And so yung iba familiar naman dito sa mga logic gate symbols. Sige, as we review, may idea ba kayo kung ano yung symbol sa number 1? Anyone? You can raise your hand kung alam nyo for number 1. Okay, sige. So, I confirm, can you confirm kung hindi pa kayo or wala kayong subject before na antinalaka yung logic gates? Or bago lang sa inyo to?
Bago lang ata, sir.
Okay, sige. Sige, for the first one, we have this OR gate. So, ang tawag dito sa number 1, and we have OR gate. And then for number 2, we have NOR gate. And then for number 3, we have AND gate. And then for number 4, we have NAND gate. And then for number 5, we have XOR. And then for number 6, we have XNOR. And then for 7, we have buffer. And then for 8, we have NOT. Ayan, so for the logic gate symbols, meron tayong 8 gate symbols, and also pag we design or we create logic circuits, ito yung commonly makikita natin na logic gate. So we have OR gate, NOR gate, AND gate, NAND gate, XOR gate, XNOR gate. We have the buffer and then the NOT. So ito yung overview niya. So pag AND gate, ito yung symbol na ginagamit, and then as you can see XY. So yung XY, ito yung input, and then yung F, here's the example output. So kung i-derive natin siya as a function, so F equals XY. So yung output na F equals siya sa input na XY. And also we have their truth table. So kapag end, as you can see, dun sa truth table niya, as long na if there's a 0 on the input, the answer will always be 0. And then if the input is both 1 or both true, the answer is true. And also for end, we use multiplication. So as we derive for the truth table or for the answer, so we have x times y. So 0 times 0 equals 0. 0 times 1 equals 0. 1 times 0 equals 0. Then 1 times 1 equals 1. So ayan yung AND gate. And also we have the OR gate. So yung OR gate naman, we have addition. So f equals x plus y. So as you can see on this truth table, we could derive that as long na true or there's 1, the answer is always be true or 1. So for this example, since we're going to use addition, so 0 plus 0, we have 0. 0 plus 1 equals 1. 1 plus 0 equals 1. Then 1 plus 1 equals 1. And then for next, we have the inverter or NOT. So we have only one input, which is x, and then the output is f. And also in inverter, we use this small dot after the symbol. And also we use the complement sign. And there's the complement sign. So meaning f equals not x. So yung answer dito, so you can see sa truth table. So not 0 equals 1, then not 1 equals 0. Then also we have the buffer. So meaning ng buffer, what is the input? Yun din yung output. So f equals x. So as is. So we have x. So x equals to 0 input equals to 0 output. Then one input equals to one output since f equals x for the buffer. And then next we have the Nand gate or not end gate. So we have input x and y, and then meron siyang inverter sign. So ang equation niya f equals complement x and y. So as you can see, the not end or none is the opposite of end. So we all know, di ba, 0 times 0 is 0. So not 0 equals 1. And then 0 times 1 equals 0. So not 0 equals 1. Then 1 times 0 equals 0. So not 0 equals 1. And then 1 times 1 equals 1, not 1 equals 0. And so, kasya na derive na ganito na not and since meron siyang complement. Ayan, ini-invert niya lang yung answer. And so we have not 0 equals 1, not 0, 1, not 0 equals 1, then not 1, 0. Then also we have NOR gate. Ito naman yung opposite no OR gate. And also we use addition. And also mapapansin niyo sa symbol niya, meron lang din siyang inverter or yung complement symbol, yung small circle. So again, we have the opposite output. So 0 plus 0, we have 0, di ba? So not 0 equals 1. And then we have 0 plus 1 equals 1. So not 1, we have 0. And then 1 plus 0, 1. We have not 1 equals 0. Then 1 plus 1 equals 1. Then not 1 and 0. And then also we have the exclusive or gate or XOR. So in this gate naman, we use this symbol. We have the extra line before the OR gate symbol for the input. And the equation will be x xy complement plus x complement y, or we have the x plus y na ganito yung symbol. And so sa XOR, we have this truth table na as you can see, pag parehas yung input ng X and Y, ang answer is 0 or false. So since we have 0 plus 0 equals 0, then 1 plus 1 equals 0. And then pag magkaiba siya, 0 plus 1, we have 1. And then 1 plus 0 equals 1. So, yun yung sa exclusive OR. And then we have also the exclusive NOR or XNOR. So we have the equation of y plus x complement y complement, or you have this symbol na x plus y. X plus y complement. So dito naman, siya yung opposite ni XOR. As you can see, kapag parehas yung input niya, ang answer will be always be 1 or true. And kapag parehas, so 1 plus 1 equals 1. 0 plus 0 equals 1. And then pag magkaiba yung input, we have x, 0, we have y, 1. So 0 yung answer. May question ba sa logic gates?
Wala po, sir.
Okay, sige. We move on for the Boolean addition. So, itatakan lang natin yung overview nung sa Boolean expression. So, we have Boolean addition is equivalent to the OR operation. So, as you can see, we have 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. Then 1 plus 1 equals 1. And then, a sum term is produced by an OR operation with no and operations involved. So for example, we have a plus b, a plus complement b, then a plus b plus complement c, a complement plus b plus c plus t complement. So makikita nyo sa addition, ayan, puro lang siya or. So yung symbol ng or, ayan, ganyan. Then wala siyang end gate. So a sum term is equal to 1 when one or more of the literals in the term are 1. And then a sum term is equal to 0 and then only if each of the literals is 0. So as you can see, magsi-0 lang yung answer niya kapag parehas 0 yung literals or yung input. Then yung output niya always 1 kapag may 1 sa input. So next, we have Boolean multiplication. So sa Boolean multiplication naman, equivalent niya yung AND operation or AND gate. So a product term is produced by the AND operation with no or ops involved or operation involved. So opposite niya naman yung Boolean addition. So dito, we have A times B, A times complement B, A times B times complement C. We have complement A times B times C times complement T. And then the product term is equal to 1 only if each of the literals in the term is 1. A product term is equal to 0 when one or more of the literals are 0. So dito, since multiplication siya, so yung answer niya magwa 1 kapag both inputs are 1. So as you can see, 1 times 1, we have the output of 1. And the rest of the sample, we have 0 times 0 equals 0, 0 times 1 equals 0, 1 times 0 equals 0. So, ayun, sabi dito, a product term is equal to 1 if both input of the literals are equals to 1. Kaya ang may answer lang na 1 dito yung 1 times 1 sa end operation. And also, we have other rules for Boolean algebra. We have commutative laws, associative, tsaka distributive laws. So for commutative, we have the sample. So the commutative law of addition for two variables is written as a plus b equals b plus a. So we have this OR gate. So we have a, b as input, and then we have a plus b as an output. Then equals daw siya sa b plus a. Ayun yung commutative law. And then the commutative law of multiplication for two variable is written as a times b equals to b times a. So, ibig sabihin sa commutative law, equal yung both two variables kahit pagbaliktarin mo yung placement ng equation niya. So, we have a plus b dito, di ba? Then, equals daw siya sa b plus a. Same here in for multiplication, we have a times b equals to b times a. Example niyan, di ba, we have 5 plus 2 equals sa 2 plus 5. And so, ang answer naman dyan, 7 yung sum. And equals lang din sila sa 7. Kahit pagbaliktarin natin yung placement ng computation. And then also we have AB equals B will equals to 3 times 1.
Ayoko, lilita ko dyan.
So we have 3 equals 3.
Kinaserox namin yung sa amin ganyan.
Ito?
Oh. Saan? Kay Alfred.
And then also we have associative law of addition for three variables is written as a plus b plus b plus c equals to a plus b multiply plus c. The associative law of multiplication for three variables is written as a times b equals a times b times c. So sa associative law naman of addition, we associate the equation equivalent to the other equation. As you can see, we have this OR gate. We have this two OR gate. We associate it with the other OR gate. So we have here as A. So we have A. And then since OR gate siya, we use to add addition. So A plus, ito, yung other input niya. So B plus C. So we have A plus B plus C. Then, ganun din siya. Equal siya sa A plus B. Equal siya dito sa equation na to na A plus B plus C. And then, other example, we have here we have A for multiplication times BC. So, we have A and then we have other input na BC. So, A times BC equals to AB and then times C. And then next you have distributive law. So the distributive law is written for three variables as follow. So we have A times B plus C equals to AB plus C. So the distributive, we distribute lang yung variable. So we have a, a times b, and then we have a times c. So dito for the example, we have x, yung output, equals to a plus b plus c. And then also we have other logic gates. We have AB. Ito yung AB. Since OR gate siya, we use plus or addition. Then we have AC. And so equals lang sila. Kasi nga distributive laws. So we have x equals a times b plus c is equals to a ab plus ac. And as a rules of Boolean algebra, ito yung pinaka-rules nila. And ito yung magiging guide natin sa rules. So, if we have a plus 0, the answer is a. So, yung a, any variable. So, it can be either 1, so 1 or 0 yung pwedeng maging value ng a. Kaya a plus 0 equals yung a. Then we have a plus 1 equals 1. And also we have a times 0 equals 0, and then a times 1 equals a. A plus a equals a. So a not complement a equals 1. And also we have a times a equals a. A times not complement a equals 0. So kapag nakita niyo yung double complement, and ibig sabihin niyan, i-revert back niya lang ulit. So, not complement A equals A. Next, we have A plus A, B equals A. And then we have A plus complement A, B equals A plus B. And then we have A plus B times A plus C equals A plus BC. So, as you can see, A and B can represent a single variable or combination of variables. And also in Boolean algebra, we have the Morgan's theorem. So the Morgan's theorems provide mathematical verification of the equivalency of the NAND and negative OR gates. So the equivalency of the NOR and negative AND gates. So sa De Morgan theorem, sinasabi lang dito na yung NOT AND na x times y equal siya dun sa negative OR gate or complement ng NOR gate. So as you can see, complement of two or more AND gate variables is equivalent to the OR of the complement of the individual variables. And also the complement of two more or variables equivalent to the end of the complement of the individual variables. And for example, we have x plus y na NOR gate is equals to negative AND gate. Ayan. And so for now, we have lang yung overview. Yung overview nung sa Boolean algebra. And also yung sa logic gates natin. Ayan yung mga symbol. Kasi by next week and we will be tackle more on more on logic gates. And kaya binigyan ko lang kayo na overview. Ayan. So may question pa ba? Regarding logic gates and Boolean algebra. Ayan, sige, sige. Kung wala ng question, yun na lang muna and then wala na muna kayong laboratory activity. Ito na lang yung nakaraan nung last Monday. So yung mga hindi pa nakapag-submit, so meron pang 12 na missing. Ayan, we have Bariso, Anel Almante, ayan, Ricardo Argame, Lubonilla, Gabriel Borromeo, Allen Cruz, John Carlo Cruz, Janine Dura, Kevin Dave Flores, Judy Ann Patron, Jeremy Lip Penaranda, and Amonaira Saed. Ayun, pakisubmit na lang. And then, and sige, kung wala nang question, sige, let's call it a day. I will be posting na lang din yung yung video tsaka yung PowerPoint presentation. Okay, thank you, class.
Thank you po.